This video is an overview of how to use TAP searches in IRSA Viewer or tools like it. If you have spent a lot of time with the Catalogs tab in IRSA Viewer, you're familiar with how to access IRSA's holdings in catalogs using this interface. You may have found the VO TAP tab that's available under IRSA search tabs. This is another way of accessing the same catalogs that are available via this tab. You might be forgiven for thinking, why? Why would this far more complex interface be available when you have this perfectly good and straightforward interface here? You would be forgiven for thinking that. I used to think that. Now I understand why this might be a more preferable interface. It is more complicated, however. Just like with the Catalogs tab where you have to pick a project and then a table, here too you have to pick a project first and then a table. Here you have ways to add more complicated constraints. Just like with the Catalogs tab, you can put in a single spatial search or a multi-object spatial search. You can put in a cone or a polygon. Just for purposes of this, I'm going to put in M16. Just like in other kinds of searches, you can resolve the coordinate with NET or SIMBAD. This interface allows you to more interactively refine your target search if you want, and it's showing you that radius on the screen reflects the true size of the radius that you're entering. I'm going to leave it as 10 arc seconds for now. Then you need to tell it what the position columns are of the catalog you're matching to. It's made a successful guess here. You could also, instead or in addition, do a temporal search or an object ID search of the catalog. In this interface, you can also impose constraints here. For example, if you know right away that you're only going to want high signal-to-noise sources, you can impose a high signal-to-noise constraint from here. But I know from experience that if we're going to request a high signal-to-noise constraint, we better increase the radius of the search that we're asking for. Now, if you're new at constructing ADQL queries, but you need an ADQL query to drop into your Python code, you can use this graphical user interface, this GUI, to populate and edit the ADQL. So what this has done is take the configuration that I edited in that GUI and convert it into the ADQL. It's going to do this under the hood anyway, but what this is doing is allowing you insight into that process so that you can, if you want, continue to edit this ADQL or copy it and paste it into your Python. Unfortunately, it doesn't go the other way, though. Any edits you make here are not propagated back to here. If you are doing a truly enormous search and you're anticipating that you're going to get more than 50,000 rows, you should pay attention to the row limit here. And this is how you change the name of the tab that's going to result from this search. I'm going to go ahead and search. It's come back with only 7 rows because we only did 100 arc seconds, and we actually imposed a pretty strict search criterion by asking it to only give us the highest signal-to-noise sources in Ys 1, 2, 3, and 4. But that's the basic idea. That's how you do a VO TAP query. There are other TAP queries buried in here as well. Multi-archive VO TAP. This search obligates you to do a search of IRSA holdings. This, while the default is IRSA holdings, it does not limit you to just IRSA holdings. You can pick searches from anywhere in the world. You can even type in your own URL if you'd like. So you can search somebody else's VO TAP service. And then this search is a special kind of VO TAP kind of query. This is called a VO OBS core. CADC is the Canadian Archive. An OBS core is a particular kind of TAP service. This is looking for data products that are out and available. So this query, I'm going to get this going. This query is going to go out and look for all available observations of M16 that is known to this CADC OBS core service. While that is continuing to think, let me go back over to the Multi-Archive VO tab. You can recover this OBSCOR service if you go to CADC and tell it to use image search, the OBSTAP service. This is the same kind of search as the CADC VO OBSCOR search is here. So if you have another OBSCOR search that you like, you can pick that service here and use the OBSTAP service there. The results from the OBSCOR search is here. So you can see that it found 26,000 and change different observations of M16 from all over the world, all sorts of other different observatories and wavelengths, and the preview of those data products are shown here. So this is a crash course in what a TAP search is. In brief, it's a much more sophisticated kind of search than you can get from the old catalogs tab. Because it is VO compliant, it starts to make available to you all sorts of capabilities that are available through the virtual observatory all over the rest of the world. For more information, there's of course online help that has more information on all of these kinds of searches.